Hello everyone. Uh, Here in this project, I designed an 8051 based system that toggles for LEDs at different frequencies using a push button and display the current mode on a multiplexed 7 segment display. Let me briefly walk you through the architecture here. Okay. Okay, at the very top, we have our interrupt vectors. In the in a initialization section, I enabled external interrupt 0 to trigger on a falling edge for our button. I also configured a timer in 16-bit, a timer 1 in 16-bit mode to handle our delays. I calculated the initial timer values required for a precise 62.5 millisecond uh, base delay and saved these values in the RAM to reload them later. Okay, here in the variables, the core state of the system is held in the R0 register. It acts as our mode tracker, ranging from 0, which is the off state, to 4. And now in the main loop here, our main loop is entirely dedicated to the 7 segment display. Instead of using two separate parts, I use multiplexing the loop continuously and repeatedly switches between the units and tens digits, fetching the correct numbers uh, from the lookup tables based on the current mode in R0. Okay, now uh, for in button ISRX 0. Okay, so how does the frequency change when the button is pressed? The hardware triggers the external interrupt inside its routine. Uh, we uh, we increment to the R0 mode. If it exceeds 4, we reset the system back to the off state. If it's a valid mode, we update the loop counter for the new frequency and exit. Okay, now timer ISR timer 1 here. The actual LED blinking is managed by the timer 1 interrupt. Every 62.5 milliseconds, the timer overflows. We reload the timer and decrement our specific loop counter. When this counter reaches 0, depending on the active mode, we can use XRL, exclusive OR instruction to toggle the state of the forlets. Then we reset the loop counter for the next blink. Okay, now here in uh, in subroutines. Okay, now here in the subroutines, at the bottom of the code, uh, I implemented subroutines to avoid code repetition when reloading the timer. doing with lookup tables that store the 7 segment digit codes and the required delay multipliers. Now, let's move on the debug and simulation phase to see it in the action. Okay, now we will run the code here. Okay, you will see here the part 3. Okay, now we will click here, and as you see, we are clicking here. Okay, we'll come back in the same loop. Okay, after that we will see here the part 3 0 1 2 here. We will click it, and now you can see the difference here. Now we return here. Okay, thank you.